While the all-seeing eye may have helped Nicolas Cage locate treasure in Disney's 2004 hit National Treasure, tonight I'm going to tell you about a different all-seeing eye developed right here at Penn State. This one is going to help revolutionize the solar energy field. That's this week's EarthBeat. Tonight, I decided to shed some light on a solar energy project under the direction of Dr. Jeff Brownson, who specializes in renewable energy initiatives in Penn State's Energy and Mineral Engineering Department.
My area of research is solar energy conversion systems, converting solar energy into useful goods and services for people. Primarily, I work on solar for electricity. The technology is called photovoltaics, and it's the direct conversion of light into electricity.
The project of the all-seeing eye was motivated by the understanding that we need better measurements of incoming solar energy. Not all sunlight is created equal, especially once it makes it to the Earth's surface. The project's main goal? To get a much clearer picture of solar radiation's directionality and how its energy varies from different points.
So, as a research team, my group has worked together to simulate the conversion of energy into power and to understand how solar energy is useful to society. In order to do those simulations, we need solar energy inputs. And what we found out was that the energy that is available to us in our numerical simulations is actually not very accurate. Effectively, we found out that technologies had shifted in about the last 20 years to become much, much less expensive than they were in an earlier age of solar energy conversion. We started researching how do you combine different measurement devices and eventually came upon the idea of pulling together multiple measurement devices, training the measurements against basically an artificial brain. And by tying together all of these measurement devices that kind of act like an insect's eye with an artificial brain, we made a new type of measurement device.
Not only was a new measurement device created, but the cost of it is substantially lower than traditional measurement devices.
So the traditional measurement devices, the radiometers out in the field that really measure high quality data tend to be called perheliometers. They are on the order of $20,000 to $50,000 for the entire system. This is not something that you're going to find next to your house. This is honestly far more expensive than you'd want even in a traditional meteorological station on a ground mount. We reevaluated what was available in technologies and tried to package them together in a smaller scale. We're down to on the order of about, $1,000 to $3,000 for the system in just the very earliest prototype stage, and we see a lot of vision to be able to drive that down significantly to below several $100s.
Given how expensive traditional radiometers are, their placement around the globe for collecting good data is nowhere close to adequate.
The main problem out there is that in society today, it's as if we don't have thermometers, but for light. So if you don't deploy these radiometers, these radiation measurement devices all over the place, you're really not collecting the data. And if you're not collecting it, you're not making decisions based on it.
And if you don't have good data to make good decisions, then we do something that is second nature to us.
So you run into the common result, which is that we use our eyes to judge whether or not we have sufficient quality of light to deploy a technology like a solar panel, a photovoltaic panel. And the reality is that you have enough light almost everywhere to deploy solar panels, and that it's actually tied to, say, financial aspects of the cost of electricity and fuels. But to change the way that people think about solar energy and the way that they think about the usefulness and the utility of light itself actually means that we need to measure it.
Dr. Brownson and his team have already deployed one all-seeing eye at a remote location just outside of State College in Rock Springs.
And it's a surface radiation monitoring network. The acronym is SURFRAD, operated by NOAA, managed here at the Department of Meteorology and Atmospheric Sciences. And the site now contains our first all-seeing eye mounted, collecting data, and the training of the brain is done at the Surface Radiation Network. So SurfRad is training our new all-seeing eye to have a brain. And we're then going to move from that station to other locations around town and hopefully eventually start deploying it all over the nation.
The growth of the All Seeing Eye project also means an expansion of the size of the group working on it. Not just more people, but more departments too.
The growth of it means that we're now trying to develop kind of a modular approach to managing a large team for this, so that we have students who are involved in prototyping and designing the actual casing that holds together the measurement devices. We have students working on new and inexpensive ways of creating data loggers, of creating little computer systems that will record our data. And we're having students think about how do we take the information that we have and visualize that in better ways. So it's actually breaking up into a lot of different groups.
Different groups with the same overall goal to create an information platform for solar energy in such a way that it can be available everywhere.
We can actually build value into light. And the interesting thing is that solar energy is everywhere. And so that means that these goods, these products that might spin off out of solar energy, whether it's agriculture or new building controls or solar for electricity, are all basically going to happen everywhere. And that new kind of change, that new kind of transformation is going to mean lots of new jobs, lots of new opportunities for entrepreneurship, and really exciting new ways that society is going to change all over the planet.
Dr. Brownson believes that with the all-seeing eye, we can create a new energy revolution that can help monetize solar energy and create new opportunities all around the world. And what a sight it will be for all to see. For Weather World, I'm Ben Reppert.